In the last lecture, we have seen how we can construct a mini heap. So now we are going to write the algorithm for this. So what will be the algorithm? Algorithm will be heapify top. We are giving the name. This is the array. This is the ith position. And this is the n number of element. So initially, what we are doing, we are assigning minimum value to the ith position. We are supposing it that at ith position we are having minimum element, and the left element will be 2 into ith position, and the right element will be l plus 1 position. And then if array of minimum element is greater than array of left, then what we will do, we will assign L, or we can say the left element as the minimum element. If the minimum element is greater than the left element, then we will assign the left element as the minimum element. And if array of minimum element is greater than the array of right element, then we will assign right element as the minimum element. And if I is equal to minimum element, if ith position is equal to minimum element, then we will simply return because this is at the correct position. Else what we will do, we swap array of element with the array of minimum element. Then heapify array minimum element and the n total number of element. So this is the way we do the we construct the mini heap. And we can say simply, or we can say there are many algorithms which we learn till now. So we can say simply bubble sort. If we do comparison, then bubble sort are like best case, average case and worst case. When we talk about the bubble sort, so best case is n square, complexity, average case is also n square, and worst case is also n square. So we can say in all the cases it is same. But if we talk about the merge sort, then best case is n log n, average case is also n log n, and worst case is also n log n. So all are same. Let's see about quick sort. These algorithm we already learned, so we are talking about the time complexity only. So quick sort, best case is n log n, average case is n log n, while the worst case is n square. So in the similar way, if we talk about the heap sort, so best case is n, average case is n log n, and worst case is also n log n. So in the similar way, if we talk about the insertion sort, so the best case time complexity is n, average case is n square, and worst case is also n square. And if we talk about the selection sort, so the best case time complexity is n square, average case is n square, and worst case is also n square. So we can say simply there are some time complexity of the sorting algorithm which we already learned. So this we can say best case, or we can say the lower bound, or worst case we can say on the based on the upper bound. So today all about how we can write the heap sort algorithm, or if we are adding the element, how we can add the element, and these are the some comparison which algorithm, which sorting algorithm we already learned.